My name is John Biddle. I'm professor of mechanical engineering at Cal Poly Pomona University. I've been here going on my 45th year now, and I teach in the thermal science area in mechanical engineering. Heat transfer in our curriculum is a senior level course, and it builds on fluid mechanics, thermodynamics in the junior level. It feeds into courses such as HVAC and several other courses in the energy field, energy conservation, and so on. So it's a very important course to take these more specific courses in your senior year. There are three major modes of heat transfer: conduction heat transfer, convection heat transfer, and radiation heat transfer. And within those areas, we then do modeling and solutions to a variety of problems, and then we combine them together near the end on how maybe a heat exchanger or how maybe a solar collector operates. So it builds into that at the end of the course. It's fascinating to me because so many jobs open up with the knowledge of heat transfer. You can take any particular job in the real world, whether it's heat treating steel, hardening ball bearings, working on a solar collector. In the middle of winter when it's cold outside, why does the inside of your car seem so warm? Explained by radiation heat transfer from the sun. So all these things are fascinating, not just to the students in the classroom, but also leading to jobs in industry. I've taught heat transfer between 90 and 100 times. But every time I find it a new exciting adventure. I'll be in front of the class, we're talking about a particular topic in heat transfer, and while I'm talking, I'm thinking in the back of my mind, I think there's a better way to explain this. When I first started teaching it, we didn't have the tools in the toolbox we have now. So the books in heat transfer, when I first started teaching it, have the basic equations and solution techniques, and the textbook I'm teaching out of now has the similar equations. The bottom line is we're really trying to teach the students the basic fundamentals and equations in the course, and then how you model that situation in the real world and what assumptions are reasonable to make. I think the fun part of it is when you relate what's in the textbook to their real lives. Your automotive radiator that we all have, how does it work? A solar thermal collector, which tends to be very interesting to many of our engineering students now. So those are the things they really enjoy, relating those topics to their real life. The hardest topic is radiation, because you really don't experience a lot of radiation in your real life. So they have more difficulty with the concepts in radiation, which build on a decent background in physics. So that's, I think, where most students have their difficulty in radiation. You've made a great choice in a major. Engineering is a fascinating career, but it's a challenging career. And as a student now, compared to when I went to undergraduate school, you've got many balls to juggle. So you have to juggle those balls and decide where to spend your time. But if you want to be a successful student, number one, you want your degree in a timely fashion. So what you've got to do is put your blinders on and look at that degree and say, I want that degree. And focus on that and immerse yourself. Immerse yourself in your degree. And if you do that, hopefully you'll be successful. If you're in a particular class, like let's say fluid mechanics, every day you go in is a different topic. And if any one day you're taking classes, maybe your first class is fluid mechanics, then maybe thermodynamics, and then maybe stress analysis. You have to shift gears in every one of those three classes and suddenly learn new material in that class. Well, when you get out with your degree and get a job, life does not change. Every day, you're going to have new material thrown at you. You have to absorb that material and find out how to use it to get a solution. So, one of the main things that we hopefully train you as a student, when you leave here, you've been taught how to learn new material. So that's what you should leave with. And because your career will change with time. There'll always be new things to go out there and find and do. So focus on how to learn new material and apply it to a solution.